Hi there, this is Akin from Step by Step Academy. I hope you're having a beautiful day, my friend, from whatever part of the world you're watching from. In today's video, I will be sharing with you how to solve number-based equations, both on simple equations and quadratic equations. Let's begin right away with the following examples. Example 1. 101 base x equals 5. The first step is to convert the numbers on both sides of the equation into base 10. Please note that when the base of any of the number either on the left or on the right is not indicated, it implies that the number is already in base 10. So 5 on the right hand side of this equation is already in base 10. So there will be no need for us to convert 5 to base 10. This is already in base 10. So all we need to do is just convert only the left hand side of this equation into base 10. Can you remember again how to convert a number in any base to base 10? The first step to do that is to assign digits or powers of 0 starting from my right towards my left. That's 0, 1, 2. The second step is to use each digit, multiply the base, raised to the power assigned to the digit. So this will be 1 times x raised to power 2, 1 times x raised to power 2, plus 0 times x raised to power 1, 0 times x raised to power 1, plus 1 times x raised to power 0, then equal to 5. Now 1 times x squared will give us x squared plus x raised to power 1, that is x. X times 0 is 0, plus x raised to power 0, that is 1. 1 times 1 will give us 1 equals to 5. This will give us x squared plus 1 equals to 5. X squared will be equal to, now if we take this over to this side, we collect like terms. So 5 plus 1, when you move positive 1 to the right hand side of the equation, it becomes negative 1. So we'll have x squared is equal to 5 minus 1, which is 4. Now the next step will be to do the square root of both sides. Remember, this is a quadratic equation, and every quadratic equation must always have two answers. So if I do square root of both sides of the equation, I should include plus or minus. So square root of x squared will give us x, and square root of 4 will be plus or minus 2. So our answer to this equation is x is equal to plus 2, x is equal to plus 2 or minus 2, or minus 2. But remember, since our base, x here stands for the base, and since the base cannot be negative, therefore this cannot be our answer. So we go for the positive value of x, which is x equals to 2. Example 2. 1 base x minus 6 equals 3 minus 10 base x. The first step here is to collect the like terms. So the ones with base x, I'll move them over to the left hand side. So 11 base x is already on the left hand side. So I'm going to move minus 10 base x over to the left hand side. And that will become positive 10 base x equal to 3 is already on my right. So I'm going to move minus 3 over to this place. That will give us plus 6. And now we're going to have 1 base x plus 10 base x equals 9. Now note again, this 9 is in base 10. Now the next step will be to convert both sides of the equation to base 10. Now we will only do that for the left hand side because the right hand side is already in base 10, just like I stated earlier, that when the base of a number is not indicated, it means the number is already in base 10. So let's go ahead and convert just the left hand side to base 10. And to do that, we begin by assigning powers of 0 starting from my right towards my left. And then this will also be 0 and then 1. The next step now will be to use each digit multiply the base raised to the power assigned to the digit. So this will be 1 times x raised to power 1 plus 1 times x raised to power 0, then plus 1 times x raised to power 1 plus 0 times x raised to power 0 equals 9. X to the power of 1 is x, x times 1 will give us x, plus x to the power of 0 is 1, 1 times 1 will give us 1, plus x to the power of 1, that's x, x times 1 will give us x, plus x to the power of 0, that's 1, 1 times 0 will give us 0, equals 9. So we have x plus x. X plus x will give us 2x. Plus 1 plus 0 will give us plus 1 equals to 9. So from here we collect like terms. I move plus 1 from the left over to the right hand side. That will give me minus 1. So that will be 9 minus 1. And I will have 2x is equal to 8. Now from here, I'll divide both sides by 2 in order to get the value of x. So 2 in 2 is 1, 2 in 8 is 4. Therefore, x is equals 4. Example 3. 2 3 base x equals 1 1 1 1 base 2. Now the first step again is to convert both sides of the equation into base 10, and we do that by assigning powers of 0, 1 starting from my right towards my left. The same for the right hand side. I assign powers of 0 starting from my right towards my left, 2 and then 3. The next step will be to use each digit, multiply the base, raised to the power assigned to the digit. So this will be 2 times x to the power of 1 plus 3 times x to the power of 0 equals 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 1 times 2 to the power of 0. Now let's go ahead and simplify further. X to the power of 1 will give x. 2 times x, that will give us 2x. X to the power of 0 will give 1. 1 times 3, that will give us 3. 2 to the power of 3 will give 8. 8 times 1 will give us 8. 2 to the power of 2 will give 4. 4 times 1 will give 4. 2 to the power of 1 will give 2. 2 times 1 will give us 2. 2 to the power of 0 is 1. 1 times 1 will give us 1. So again we have 2x plus 3. Now add up all the numbers on the right hand side together. 8 plus 4 is 12, plus 2 is 14, plus 1, that's 15. Now from here we collect like terms. 2x will be equals, take plus 3 over to the right hand side, that will become negative 3. So we have 15 minus 3. This will now give us 2x equals to 12. Then from here we divide both sides by 12. By 2 rather. So 2 in 2 is 1, in 12 is 6. Therefore, x is equal to 6. Therefore, the base here is base 6. Example 4. We have 315 base x minus 223 base x equals 72 base x. The first step again is to convert each number to base 10. We begin by assigning powers of 0, 1, 2, 0, 1, 2, 0, 1. Now the next step is to use each digit, multiply the base, raised to the power assigned to the digit. So we have 3 times x raised to power 2 plus 1 times x raised to power 1 plus 5 times x to the power of 0 minus, now remember to put all of these in bracket because of this subtraction sign. So 2 times x raised to power 2, that will be 2x squared, plus 2 times x raised to power 1, that is 2x raised to power 1, plus 3 times x raised to power 0 equals 7 times x raised to power 1 plus 2 times x raised to power 0. Now let's simplify further. This will give us 3x squared plus x to the power of 1 is x, x times 1 is x, plus x to the power of 0 is 1, 1 times 5 is 5, minus, now let's clear this bracket, this will be minus 2x squared, minus times plus, that will give us minus x to the power of 1, that's x, so this will be 2x, minus again times plus, that is minus x to the power of 0 is 1. 1 times 3 will give us 3. X to the power of 1 is 1. 1 times 7, that will give us 7x. X to the power of 0 is 1. 1 times 2 is 2. Alright, from here, now let's collect like terms. 3x squared minus 2x squared, that will leave us with x squared. Now x minus 2x, that's minus x. Minus x. Then plus 5 minus 3, plus 5 minus 3, that will give us plus 2, equals 7x plus 2. Now this will lead us to a quadratic equation. So we have to move every other thing to the left hand side and make the equation equal 0. So bring positive 7x over to the left hand side. That will be x squared minus x minus 7x, then plus 2. Then bring positive 2 also to the left hand side. That will be negative 2 equals 0. Now we have x squared minus x minus 7x. That's minus 8x. Plus 2 minus 2 will give us 0. So we have equal to 0. So we have this quadratic equation, x squared minus 8x equals 0. Now if you look at the two terms, x is common, so we can factor out x. This will be x minus 8 equals 0. Therefore, our answer is either x is equal to 0 or x is equal to x minus 8 rather equals 0. Then if we solve this further, we have x equals to 8. Now remember again that your base is usually greater than 0. So x cannot be equal to 0. Therefore, we go for the option x equals to 8 since our base cannot be 0. So x is equal to 8. Lastly, example 5. We have 1, 2, 4 base x equals 2, 3, 2 base 5. Again, convert both sides of the equation into base 10. This is 0, 1, 2. This is 0, 1, 2. The next step is to use each digit, multiply the base, raised to the power assigned to the digit. So 1 times x to the power of 2. That will be 1 times x raised to power 2 plus 2 times x raised to power 1 plus 4 times x raised to power 0 equals 2 times 5 raised to power 2 plus 3 times 5 raised to power 1 plus 2 times 5 raised to power 0. Now this will give us x squared plus 2x. X to the power of 0, that's 1. 1 times 4 will give us 4. 5 to the power of 2, that's 25. 25 times 2 will give us 50. Plus 5 to the power of 1, that will give us 5. 5 times 3 is 15. 15. Plus 5 to the power of 0, that is 1. 1 times 2 will give us 2. So x squared plus 2x plus 4 equals, now add up all of these together. 50 plus 15 is 65 plus 2, that's 67. Then we have x squared plus 2x plus 4. Again, this is a quadratic equation. Therefore, we move plus 67 over to the left hand side. That will become negative 67 equals 0. And now we have x squared plus 2x plus 4 minus 67. That will give us minus 63 equals to 0. Now we end up with this quadratic equation. Now how do you solve this quadratic equation? Don't worry, I'll be making a video shortly on how to solve quadratic equation. But for now, the procedure is to multiply the first and the last term. That will give us minus 63x squared. Then we look for factors of 63. Factors of 63. That will be 7 and 9. 7 and 9. So how do I combine 7 and 9 to get plus 2? How do I combine 7 and 9 to get plus 2? So I'm going to say 9 plus 9x minus 7x. That will give me plus 2x. Therefore, this 2x in the middle will be replace with plus 9x minus 7x. Plus 9x minus 7x. So we're going to have x squared plus 9x minus 7x minus 63 equals 0. Now, we group this x squared plus 9x. The common factor between both terms is x. So factor out the x. This will remain x plus the x is already factored out from this. This will remain 9. Now come to these two terms. So we factor this. 7 is common. So minus 7 rather. We factor out minus 7. So this will remain x. Negative 63 will become plus 9 equals 0. Therefore, if you look at these two terms again, the common factor is x plus 9 is common to both terms. So this will leave us with x minus 7. X plus 9 has been factored out from this term. So this term is remaining x. X plus 9 has also been factored out from this is remaining 7. So we have either x plus 9 equals 0 or x minus 7 equals 0. Now if we solve the two equations further, we'll have x equals to minus 9. If we take positive 9 over to this side, that will be 0 minus 9. That will give us negative 9. Or take negative 7 over to this side, that will be positive 7. Again, since our number base cannot be negative, we cancel out x equals to minus 9. Since the base can never be negative, therefore our answer for x will be x equals to 7. This is how you solve equations involving number bases. Thank you for watching this video, and please subscribe, comment, and also look forward as I post more videos in the coming future. Thank you for watching and have a beautiful day.